Okay, and continuing on with our 4344 review notes, we are now going to be asked to solve by factoring. So the difference between the problems we had before and the problems that we're going to do for 3 and 4, before we stopped when we got to our parentheses, right? Our boxed final answer contained parentheses, but this time when we're asked to solve or find the roots or find the zeros, we want to get final answers of, hey, x equals this. So we'd set those parentheses equal to 0 and solve for our variables from there. So in example 3, we always start by factoring by looking for a GCF. Is there a number we can take out of 16x squared and 36? Yeah, we can take 4 out of both of those. So again, we're going to divide it out, but we don't get to throw it out the window. We just gently set it aside. 16x squared over 4 is just 4x squared. Minus 36 divided by 4 is 9. Still equal to 0. Now from here, when you only have 2 terms, remember that your only 2 options are GCF or dots. We already took a GCF out, and sure enough, we're also left with dots. We have 2 perfect square terms, so those are going to become 2 sets of parentheses, 1 plus, 1 minus, still equal to 0. The square root of 4x squared, well, the square root of 4 is 2, square root of x squared is x. So 2x goes first in both sets of parentheses. Then the square root of our last term, 9, is going to go last in our sets of parentheses. So square root of 9 is 3. But now we're asked to solve. So we set our first set of parentheses equal to 0, and our second set of parentheses equal to 0. So solving our first set of parentheses, we subtract 3, 2x equals negative 3, and we divide by 2. Just leave it as an improper fraction, totally fine. Negative 3 halves. And then our other one, we add 3. 2x equals positive 3. Dividing by 2, x is a positive 3 halves. Now, do we have to do anything with that 4 we took out? No, because it did not include a variable. If we divided out a GCF that contained a variable, like if I could take 4x out of both terms, great, we would also have x equals 0. But if you try to set that guy equal to 0, 4 is equal to 0, what? No. So we don't get any additional solutions from there. Our only 2 values for x that would cause this left-hand side to be equal to 0 are 3 halves and negative 3 halves. In example 4, we are again solving by factoring, so we will again get answers of, hey, x equals something, or a equals something, whatever. And there's 2 ways that we can factor this one. If we notice it right away, we'll notice that it's a perfect square trinomial. We can square root our first term and square root our last term. But if you don't notice that, that's totally fine. You just factor it like normal. So I'm going to do it that way because that's probably the way that we would do it if we weren't told, hey, it's a perfect square trinomial factor or pattern. So we start by doing divide inside. We multiply a and c. 9 times 1, we get 9. What numbers multiply to 9 and add to give us 6? Oh, 3 and 3. So we set up a and 3, a and 3. My signs are the same. They're both minus signs. But now we divide inside. Divide inside by that leading 9 and reduce both of these. So 3 over 9 reduces to 1 over 3 in both cases. And so we are sliding that 3 for both. 3a minus 1, and again 3a minus 1, which is how our perfect square trinomial pattern works. We could also write that as 3a minus 1 squared, right? Because when you square something, you take it times itself. So we've got 3a minus 1 times 3a minus 1 equals 0. Well, if we set both sets of parentheses separately equal to 0, you'll notice we end up getting the same thing for both. So we really only have to do it one time because it's identical. It's an identical set of parentheses. So we solve by adding 1. 3a is 1, and dividing by 3, we find a equals 1/3 for both. There's our final answer. Now, we can use these in order to solve very slightly more complex problems. So in example 5, we've got a border around a pond, and it's x feet wide. Cool, all the way around. The pond is 10 feet by 14 feet, so that information is not given to us in the picture. So that must be the 10, that's the 14 feet. And the combined area of the pond and border is 221 square feet. What is the width of the border? So we are apparently asked to find, x. Well, we know that the total length of the entire border plus pond is going to be, let's see, it's 14 from here to here, and then we add on x over here and x over here, so that's going to be 2x's plus that 14, right? Because we have x plus x would give us 2x. So the entire length is 2x plus 14. The entire width is going to do the same thing. Well, if it is 10 from there to there, we add on a border of x in this direction and in this direction. Well, that's going to be 2x plus the 10 that was already there. And we can solve from here. Now that we know that the total length is 2x plus 14 and the total width is 2x plus 10, if we know the total area is 221, well, I'm going to use the fact that area equals length times width. So 221 equals 14 plus 2x, or I guess we wrote it as 2x plus 14, times 2x plus 10. Now, remember when we solved these problems, we had to FOIL, then move the 221, then factor again. So as we FOIL this guy out, the 221 on the left stays. 2x times 2x. F in FOIL stands for firsts. So 2 times 2 would give us the 4. X times x will give us x squared. First, outside, 2x times 10, 20x. Inside, 2x times 14 is going to give us 28x. And our lasts are going to give us 140. We can combine like terms. We've got 20x and 28x. There's a 48x for you. 4x squared plus 48x. Now, while we're at it, let's go ahead and move that 221 to the other side by subtracting. 140 minus 221 is going to give us, a negative 81. And then from here we factor. So we are not able to take a GCF out of anything, which is a real bummer. So we get to use divide inside. So we'll multiply 4 times 81. Let's see, 81 times 4, 324. Okay, what numbers multiply to 324 and subtract to give us 48? Those numbers are going to be 6 and 54, right? Because 54 times 6 will give us 324. 54 minus 6 will give us that 48 that we need. So we go x and 6, x and 54. Our signs are different. Our bigger number is positive x plus 54, x minus 6. And now we get to divide inside by that leading term of 4. We are able to reduce both of these. 6 over 4 reduces to 3 over 2. Slide that 2. 2x minus 3. 54 over 4 we're able to reduce by 2. So we get 2 on bottom. We'd get 27 on top, right? Yeah. And then we slide that 2 again. But we are asked to solve, so we set our parentheses equal to 0 and solve from there. This guy would give us 2x minus 3 equals 0, 2x equals 3, or x is 3/2. That second set of parentheses is going to give us a number that doesn't necessarily make sense. So having a negative 27/2 for a border width, doesn't really make a whole lot of sense. So even though that was a solution to our equation, it didn't make sense in the context of our real world example. So our final answer is actually going to be x is 3/2 or 1.5 feet, right? Because everything is in feet, yep. for our border all the way around. So we've got our pond, and then we go 1.5 feet out in every direction. And that gives us the combined area of 221 square feet total. So the border is 1.5 feet. Okay, now use the remainder of class time to work on that green review worksheet. We will discuss that tomorrow as we move into graphing parabolas.